Now we introduce other parameters of the two-port network. The first is the R parameters, that is the resistance parameter. The R parameters means using the port currents I1 and I2 to describe the port voltage U1 and U2. The G parameters equations use U1 and U2 to describe I1 and I2. We can solve U1 and U2 from these equations. And this is the result. In fact, these coefficients are the R parameters that we want. We can mark them as R11, R12, R21, and R22. The delta equals G11 times G22 minus G12 times G21, which is the determinant of the G matrix. Please think about this question. Is this derivation suitable for any two-port networks? Obviously, it's conditional. That's a determinant of the matrix G shouldn't be equal to 0. Otherwise, the denominator is 0. In other words, for any two-port network, its G parameters and R parameters may not coexist. In fact, other parameters have the same problem. This is a second reason why we need so many parameters to describe the two-port. Since not any two-port network may have all the 6 sets of parameters, maybe only 1 or 2 of them, then we need different parameters to describe different two-port networks. Let's see the property of the reciprocal two ports R parameters. We've known for a reciprocal two-port network, it's G12 equals G21. According to the relationship between the G parameters and the R parameters, we get R12 equals R21. This is the condition that the reciprocal two ports R parameters should satisfy. For the symmetrical two-port, besides G12 equals G21, G11 equals G22 as well. According to the corresponding positions of G11 and G22 in the R parameters, we get the condition for the symmetrical two-port is that G12 equals G21 and G11 equals G22. They are similar to the conditions of the G parameters. For the same two-port network, if its matrix of R parameters and the G parameters coexist, the relationship between them is that R equals G's inverse, or G equals R's inverse. In other words, they are inverse matrices of each other. You should pay attention to this. Now we introduce a method to find the R parameters. Of course, we can find it by the experimental measurements. This is the R parameter equations. If R2 equals 0, that is port 2 is open, then R11 equals U1 over I1, and R21 equals U2 over I1. Similarly, if I1 equals 0, that is port 1 is open, then I12 equals U1 over I2, and R22 equals U2 over I2. Since we can find the R parameters by letting two ports be open, R is called the open circuit resistance parameters. Here is an example. Find out the R parameters for the two-port. This is the R parameters equations. The first method is the experimental measurements. Letting I2 be 0, that is, port 2 is open. Then R11 equals U1 over I1 equals RA plus RB. R21 equals U2 over I1. I2 equals 0 now, so the current through RB is I1. Thus, U2 over I1 equals RB. Letting I1 be 0, that is, port 1 is open, to find R12 and R22. R12 equals U1 over I2 I1 equals 0 now, so the current through RB is I2. Thus, U1 over I2 equals RB2. R22 equals U2 over I2 equals RC plus RB. This is a resistive two-port network, so it's a reciprocal two-port. So R12 equals R21. They are both equal to RB, which proves that the result is correct. For this network, further, if RA equals RC, obviously it will be a symmetrical two-port. So R11 should be equal to R22. If RA equals RC, it's obvious that R11 equals R22. Well, this is the first method. The second method is to write out the port voltage-current relationship directly. Remember now we want to use I1 and I2 to describe U1 and U2. U1 equals RA times I1 plus RB times I1 plus I2. This is a loop including U2. U2 equals RC times I2 plus RB times I1 plus I2. Rearrange these two equations, pick out the coefficients of I1. U1 equals RA plus RB times I1 plus RB times I2. And U2 equals RB times I1 plus RB plus RC times I2. Compare the coefficients. The result of this method is the same as that of method 1. It satisfies the condition of the reciprocal two-port as well. Reviewing the example that we used to find the G parameters, the network is a pi-type network. This example to find the R parameters is a T-type network. In fact, you can find that for a pi-type network, it's easy to write out its G parameters. And for a T-type network, it's easy to write out its R parameters. Please remember this conclusion, and we will use it in the two-ports equivalent circuit.